All right, we ready? Okay, wonderful. For the guys in the room, if you guys want to come up and be closer to the screen or closer to the front, it'll be a lot easier for you. And I'll make sure that these slides are going to be online someplace in case you guys want to copy. So very quickly, thank you for being here. My name is Nima Beatty. I run business development for the Cloud Foundry product group at Pivotal. And if you guys don't know, Pivotal is a software company that was founded as a carve-out or spin-out of EMC and VMware about 2.5 years ago. I started my career building airplanes, went into building computers and Unix servers for Sun Microsystems, then slowly kept moving up the stack because I found more value in the application side of the house and building things than it was in actually building these large monoliths that would take 10 years or a decade of your career to get out the window. I've been on the Cloud Foundry product team for the better part of almost 4 years now. So I actually left another infrastructure company specifically to come and work on Cloud Foundry just because I had so much passion for it and I really wanted to work on something that was part of an emerging cadre of technologies, but also solved a lot of the big problems that I myself had suffered through as a developer and as a product manager. So purpose of the talk is pretty straightforward. AppDynamics and Pivotal have been collaborating for the better part of a couple of months, actually better part of a year now, to be able to get Cloud Foundry and AppDynamics customers running their applications on top of Cloud Foundry, to be able to properly monitor the applications and to have a solution that's jointly backed by both AppDynamics as well as Pivotal. And we're really interested in working closely with our customers. Anybody in the audience running Cloud Foundry? Just raise your hand. Running AppDynamics? Running both. Okay, we're going to come talk to you guys. To really get to talk to you guys and find out how you're using the solution, what more would you like out of it, what's critical to you, what's information versus intelligence and whatnot. So before I jump into that, I'm going to talk about this kind of emerging topic called cloud native. Anybody heard of what cloud native is? Have an opinion about it? Not yet? All right, so very, very in a simple terms, cloud native is really the ability to build declarative and durable application. It's built on 12-factor principles and run using cloud agnostic platform resources. So the idea is it should be able to run pretty much anywhere. It's an API-first mentality using composable microservices to scale loosely coupled services and backing services, very similar to how Netflix operates, for example. The idea is to eliminate waste and any kind of repeatable processes by automating manual or otherwise scripted tasks that we most often see in DevOps. And to have every push and every code update be committed to production using proper continuous integration and continuous deployment pipelines. For those of you guys who are not familiar with what 12-factor is, it's a set of best practices that was originally authored by the team at Heroku for developing and deploying cloud-native software. The practice principally translates into what we call platform features and workflows, but I'll cover that in a little bit. So why is cloud-native important? It's critically important for Pivotal as well as a lot of our customers because what we've noticed is that time to market is probably the most important business imperative that our customers have. And if you can't iterate on your application quickly and deploy and develop and deploy, applications in a timely fashion, you are what is commonly now known as legacy. And honestly, nobody really wants to manage legacy applications, let alone be considered legacy. And the bar has been set. Right, so the competition, the companies that we admire the most, like the Ubers, the Facebooks, the Googles, the Amazons, they have set the bar very, very high. They're able to ship code 30 times faster than traditional enterprise organizations. They have fewer failures in deployments. They have more moving parts and can actually deploy even faster than they can develop software. Sounds pretty easy, right? We can all kind of embrace the cloud native model. It's as simple as just draw 2 circles and then the rest of the owl. Not too hard and not too difficult, but somewhere in between. And this is really how we at Pivotal apply it. So first and foremost, we're a company of roughly 800, 900 engineers building front-end, back-end, system, mobile, web, and IoT applications. We embrace extreme programming. We embrace pair programming, so the majority of our development is done in pair teams. We use tools like Pivotal Tracker to write stories. Instead of having a very complicated and long engineering specification document, we actually write stories about how we want to build software and the functionality we want it to have. We write the tests for the code before we write the code so that we can actually integrate that into our CI/CD pipeline. On average, we have between 90 and 95% test coverage across all the software that we've developed. We fully embrace the 12-factor app model, so our applications can run unencumbered on platforms like Heroku or Cloud Foundry. We partner with companies like AppDynamics and Netflix in this example to bring a lot of their composable microservices, things like Eureka, Hystrix, Turbine, Zool, and most recently Spinnaker, to the platform via the principal application interface, which in this case for us is Spring Boot and Spring Cloud Services. We have partnerships with CI/CD toolchain providers such as GitLab, CloudBees Jenkins, JFrog Artifactory. Not only do we use them ourselves, but we actually compile and compose those tools as services, as add-on services for the Cloud Foundry platform. We've also built a lot of open source tooling that wires these all together in glue code, such as Concourse, which is our pipeline solution, and various other open source projects that we've released. We strongly believe in being cloud agnostic, so we partner with VMware, OpenStack, Amazon, Azure, and to be released at some point in 2016 with Google, to be able to deploy Cloud Foundry on all the popular infrastructure providers and all the popular infrastructure platforms. So that as a consumer, as a developer, as an IT person, as a head of ops, I can run applications on top of Cloud Foundry on virtually any infrastructure. And I don't have to codify my application specifically to run on one infrastructure versus another. And the last is really to bring the processes, the culture, the components of DevOps as close to the dev team as possible. Even having them be coincident on the same team, giving developers access to some of the DevOps tooling so that they can be more responsible for the code that they develop and deploy themselves. All of this is to enable this. Now, this is the innovation cycle, and it's composed of basically 3 rings. The inside ring is the business requirements, and we know the business requirements change on a very fast basis, principally because the business is trying to catch up with a market that's ever changing. Traditionally, what we see is we have a tight coupling between business requirements and the developer loop, where we can build applications pretty quickly. But like the orbits of the planets or planetary gears, we see that the outer ring often goes a lot slower than the inner rings. And that's an impedance mismatch between the needs of the business and the ability of the rest of the company to execute. The ideal scenario, which is almost impossible, is to have all 3 rings rotating at the exact same rate. So the business imperatives and requirements drive development, which can release that product as quickly as you can develop it. So this is kind of our vision for what is Cloud Foundry. Anybody know about the history of Cloud Foundry? So very, very quickly, Cloud Foundry was started as an open source project back in 2011 at VMware. It was designed principally to meet a very large, very untapped, very unmet market need to be able to bridge the gap between infrastructure and software as a service. Right? There is this aging middleware that exists in the middle that I can buy from very large companies, but they don't really fit my need, and they're really monolithic and almost impossible to manage. When we formed Pivotal and carved out of VMware, we took this as kind of one of our principal pillars and became part of our principal business group. And in 2014, with the help of some of our partners, we launched the Cloud Foundry Foundation. And the idea behind it follows very closely with an African proverb. It says, if you want to go fast, go alone. If you want to go far, go together. So with 50 other partners, actually 20 other partners initially, we founded the Cloud Foundry Foundation. And the idea here was we didn't want to have a benevolent dictator. An open source project really shouldn't have just one company standing behind it. There should be a lot of companies, not only standing behind the project, but also contributing back to it. So what we really have is a contributory meritocracy among this kind of growing list of 50 plus companies. Not only are they platform providers, infrastructure providers, technologies, and ISVs in very specific verticals, many of them actually use Cloud Foundry to operate their own cloud, their own managed service and their own complete stack. So IBM Bluemix is built on top of Cloud Foundry and OpenStack. HP Helion is built on top of Cloud Foundry. We run our own Heroku-like Pivotal Web Services, which allows you to interact and push applications to Cloud Foundry without having to actually install software and on a distributed system. About 6 months ago, we discovered that the government themselves, through 18F, have started a Cloud Foundry-powered cloud called cloud.gov. So getting into the nitty-gritty about what Cloud Foundry is, and I want to talk about this before we talk about how we've integrated with AppDynamics. Cloud Foundry is really comprised of effectively 4 layers. At the very, very top layer, you have the application framework. And these are all the tooling that an app developer would have to be able to interact with an application hosting platform. So we've used tools like Spring Boot and Spring Cloud Services to be able to get developers to build apps as quickly as possible with pre-configured and pre-initialized systems and tools and processes. The second layer of the stack is really the heart of Cloud Foundry, what we call the elastic runtime. And this layer is really the intersection between where the developer and the IT operations person start to interact with each other a lot. And it contains a lot of the components that you'd expect to see inside of that kind of middleware layer, including a self-servicing APIs, the ability to auto-scale your applications, container management and orchestration, all the way through the first of the 4 layers of high availability built in to Cloud Foundry, which allows your applications to self-heal, the containers to restart, the VMs to recover from failure, network, the entire stack to basically heal from unforeseen circumstances, all without human intervention. So I don't really need a babysitter from IT sitting there hoping that Cloud Foundry recovers. It's actually designed to recover by itself. Along the way, we've also integrated a lot of the APM tooling and integrated logging into the platform because we want the Cloud Foundry to be as transparent as possible and not this preconceived black box that a lot of people had initially thought was this thing that's called PaaS. The lower 2 layers are really around infrastructure automation and the infrastructure itself. And this is where we use a tool chain called Bosch. It's an open source tool chain that was originally modeled after Google's Omega and Borg product to deploy highly distributed systems across multiple VMs, upwards of like 10,000 VMs. And we've written bindings to allow Cloud Foundry to deploy equally on top of AWS as it does on vSphere and OpenStack using the same basic primitives. So this is basically the 4 layers of the stack, and when I put them all together, what I see is I have a full service platform that allows me to articulate certain contracts between how the different layers work together. And the contracts are really the processes that we've all agreed upon that we're going to follow. So 12-factor model between the application framework and the runtime platform, all the way through what we consider to be a Bosch release and a cloud provider interface. Okay, so Pivotal Cloud Foundry, let me back up 1 second. Cloud Foundry exists in basically 3 principal flavors. There's the open source project. There are commercial editions of them. Pivotal provides one called Pivotal Cloud Foundry. IBM has one called Bluemix, HP Helion. And then there are hosted editions, which are basically very Heroku-like. And we have one called Pivotal Web Services. And it starts with basically the 3 principal interaction components, which are there's a robust API set that allows you to interact with the platform automatically. There's a command line interface, which is really our principal tooling to be able to interact with the platform, and a web-based GUI, which makes it very easy for us to visualize a whole host of information so that I can very quickly create graphs and create kind of visualizations that I can interact with to understand the state of my application, state of my system, the services that I use, and whatnot. The idea of kind of uploading an application, pushing an application is really designed around intent. So we use a lot of declarative semantics in the platform. The idea is that I can just push my application into the cloud and somehow magic should happen and it should run by itself. And that's not too far from the truth. So I use a command called cfpush for my command line interface, and what it will do is it'll upload my bits from my laptop up to Cloud Foundry. I'll be able to, what it will do next is it will stage my application. It will use industry popular build packs to compile my application into container code and then start my application. And from there, I can scale my application from 1 to n number of nodes, scale the routes that are connected to that application instance, and scale all the services that are connected. So for example, when I push my application, I can require that a database be connected to it, or monitoring from AppDynamics be turned on. And as I increase the number of instances that I want for n+1 scalability, all those bindings are automatically carried through for all my application instances. I can deploy any app immediately. We support the build pack methodology, which allows me via command line interface to not only start my application, start, stop, delete, reboot, and scale up and down, but also to add any type of add-on services. So if I want an SMTP server exposed as an API, I can do that. I can connect to external database services like, let's say, Mongo HQ or Compose. I can connect to things like AppDynamics. I can connect to Oracle DBAS, whatever I need. And the build pack methodology carries forward and allows me to have a truly polyglot platform. So all the traditional LAMP stack runtimes and frameworks are supported. And with the latest release, I believe we also support Microsoft. So you'll be able to run .NET and LAMP stack applications coincident on the same platform. And with the support for Azure coming through, you actually have a truly polyglot platform. We talked about scalability. The key here isn't that I can just scale the application. The key is that all the services that are bound to that application also scale along with it. So if I have a database connected to my application and I scale from 1 instance to 10 instances, I add 10 additional connections. And I don't have to, as a developer and operations person, go in and manually reconfigure that. I just give a single imperative command, or sorry, a declarative command, cf scale, and the number of instances I want. And within 30 seconds, I've got more versions of my application running. And then I can do fancy things like blue-green deployment to see if the new version of my application is working properly. There's also a robust marketplace of services. So I can basically create a binding to any service that's either within the 4 walls of my IT organization, in my company, or off the greater internet, and expose those as services to Cloud Foundry. And this is really important because when we start taking a look at what software developers actually spend time on, turns out, half of their time, and upwards of 80%, is actually wasted on administrative tasks. And we think that's not a really valuable use of an expensive engineer's time. Developer is there to build value. You build value in software that becomes services that a company sells. But if they're spending time on administrative tasks and things that they shouldn't be doing, chances are we can probably automate a lot of that. So that was the premise of Cloud Foundry. Ansi Fakuri, who's our VP of Engineering, wrote this brief haiku. And this is kind of the litmus test that we use in terms of, are we building it the right way? Right? Here's my code. Run it in the cloud. I don't care how. That's it. I don't want to be involved in the rest of this. And that's really the premise of Cloud Foundry. And this premise not only speaks loudly to us, but it has spoken loudly to a lot of our customers as well, who've seen the value of using Cloud Foundry to build kind of their next generation applications, platforms, and whatnot. I had actually more slides in terms of what the customers are doing with it, but I figured in the interest of time, I'd spend more time on the actual integration. Fun fact, we have, there are users out in kind of the greater domain that use Cloud Foundry open source as opposed to any of the commercial versions. For example, WebEx runs on top of Cloud Foundry. Baidu's backend ad serving engine runs on top of Cloud Foundry. And we're seeing more and more companies actually adopt Cloud Foundry as a new kind of operations and middleware pattern. So that's great to see that it's not just pivotal pushing our customers in that direction. Okay, let's talk about the integration and what we did. So when we talk about application performance monitoring, let's kind of layer the stack in and talk about what really needs to be measured. So at the atomic level, what we really care about is our app. And our app can be one app, it can be multiple instances of an application, and chances are that application sits inside of a container, because that's what the modern infrastructure looks like. Well, if it sits inside of a container, I'd also like to know the health and state of that container, and some metrics about how the container is performing, and possibly how the underlying virtual machines where the container is running, or even the host bare metal is operating. So every layer of the stack, as I grow outside of my application, has more and more richer contextual information that I can probably use to determine the health of my stack or monitor the performance. In addition to the host, there's a whole kind of very varied and vagaries of networking that I need to actually track. And then the routes where my application traffic runs through. So whether it's HTTP traffic or UDP and TPS traffic coming through, how do I manage that traffic? What do I use it for? And then there's always a whole host of add-on services that can be bound to my application or applications. And all of this is part of a platform, which in itself probably generates a whole host of other metrics and whatnot, which is great. And it says, all right, no, well, if the Cloud Foundry team is actually responsible for everything in this blue box, why not just build our own APM solution? Makes sense, right? Yes, but the reality is that APM is really a solved problem. And we make the distinction between information and intelligence in this context. So I get information from the platform. I get intelligence from my APM tooling. By partnering with AppDynamics, we're able to focus more on providing the instrumentation and free our team to focus on how they can provide the instrumentation necessary to provide the information, as opposed to building anything that's very, very sophisticated to give me a lot more intelligence about what I'm looking at. So I think in principle, we all agree APM is great, but the challenge that we run into is that getting started monitoring applications on top of Cloud Foundry was difficult. First, you have to read the instruction manuals. Then you have to go create an account, download the agent, figure out which agent you had to download for which application, runtime, and framework. You have to figure out how to upload it, manage your keys, instrument the application, get the instrumentation started, get the application restarted or restaged, log into your dashboard, and then your app, for whatever reason, restarts. And then now what? It's a little bit frustrating. What we recognized was that the act of turning on and monitoring an application, actually instrumenting, was pretty much of a repeatable pattern. And if it's a repeatable pattern, why don't we just automate it? That way, the user doesn't have to be on their own volition trying to figure out how this can be done. Okay, so let's talk about how this works from the developer's perspective. When I physically push my application to Cloud Foundry, what it does is that there's a detect logic within Cloud Foundry which will test my application against kind of known application runtime phenotypes. And if it identifies it, for example, I'll use a Java application. I'll say, all right, I've identified this WAR file that you've shipped up as a Java application, so I will use a Java build pack. And what a build pack is basically a convenient way of packaging frameworks and a runtime to support an application. So imagine it's a blueprint that describes the environment that the application has to run into. But what's really powerful about a build pack is that I can actually add more logic to it. So in the case of AppDynamics, what we've done is we've added detect logic inside the build pack that will detect if there is AppDynamics running as a service. And if there is, and if in the user's application manifest, it has noted that they want to have AppDynamics turned on, the system will actually automatically instrument the application for you, which means it will go and fetch the application. It will fetch the agent, embed that agent into the container runtime, and turn that agent on, the application on. The second part of this is really the service broker. So it's two components. There's the agent in the build pack, which instruments my application. And then there's a service broker, which automates the connectivity between the service, which is Cloud Foundry, AppDynamics, and Cloud Foundry. So I actually need both parts to work correctly. And the service discovery is really important because you have this bifurcation inside of Cloud Foundry where Cloud Foundry is responsible for all things application related. All things service are actually a construct outside of Cloud Foundry and are managed via provisioning APIs that we call the service broker. All right, so let's dig down a little bit into the key components. And there's principally three of them. So the first one is a machine agent. And in this case, for the Java example, the AppDynamics machine agent is just a Java application that consumes system and runtime information. And that it can pull this information either directly from the agent itself or from the Ops Metrics plugin that we have for Cloud Foundry. So the idea is I now have a thing that collects information from my app, from my container, possibly my VM and my stack, and is able to transmit this back to AppDynamics. The second part is the service broker. Service Broker is similarly an application, in this case, an application that we wrote in Java, that provides an endpoint for the AppDynamics controller to connect to Cloud Foundry. And using the Service Broker, we can actually automate the discovery and connectivity of our interaction with AppDynamics. So license discovery, key management, all of this can be actually handled by the Service Broker. It makes it a lot easier because as a developer, I don't have to know my keys. Those keys kind of been pre-provisioned and stored for me on the platform via an IT administrator. And now I'm free to use this interaction with AppDynamics more of a self-serve model, like a vending machine. So these are the two parts I need, machine agent and service broker. And what we do for our customers is actually bundle the whole thing into a binary executable that our customers can download from our website. As they're installing Cloud Foundry for the first time, they can actually upload this as an add-on service. So now they have AppDynamics performance monitoring for Cloud Foundry right out of the box. Oops. There's a lot of words on this page, and I did that on purpose because I wanted to capture explicitly what the developers told me instead of my own interpretation of it. So this is the actual word of mouth of babes. I will post this presentation somewhere so that you guys can download it and read through it yourselves. All right, so let's walk through this step by step and figure out how this thing would actually look. All right, I've talked about the concepts. Now we're going to actually go through the process. So the first thing I do is I get online and I go to network.pivotal.io. That's the URL. And that is where I can download Cloud Foundry. I load all the bits and pieces I need for Cloud Foundry, and it comes as a nice big OVA file or an AMI, depending on which infrastructure you're trying to deploy to. And along with it, I can actually download from a catalog of add-on services anything else I might need. So I'll pick up the Pivotal Ops Metrics package as well as the AppDynamics Service Broker tile. And when I first install Cloud Foundry, we have a command line interface in Bash as well as a GUI called Ops Manager. And the GUI makes the installation very, very simple because I simply upload the thing that looks like a tile. It renders itself as a tile in this management console. And I can click on the tile and go through various configuration screens. So let's click on the AppDynamics Server Broker tile. And here's where I can actually configure the service broker settings and customize them if I want. I can configure the machine agent and the machine agent extensions. And once I've installed it and hit install and deploy and come back, go get coffee, come back, what will happen is in my application console in Cloud Foundry, there is a link for a marketplace. So think of like a catalog of add-on services that are available to me as an application developer that I can start and connect to my applications. Well, now I have AppDynamics available to me and virtually anybody in my organization, in my department, whatever IT deems available as a resource. So I don't have to go through IT anymore. I don't have to submit a DevOps ticket to get access to AppDynamics. This is now actually accessible as a provisionable service for my applications directly from the Cloud Foundry console. So if I select the AppDynamics service, I can also be exposed to additional layers and services underneath it, like service plans. Maybe my company, my organization has a multi-tier structure with AppDynamics where there's a fair bit of free services, and then there's more expensive services that have departmental chargebacks. All that can be done within Cloud Foundry and the service plans. So I'll pick a plan. In this case, we've only got the one. And then from within this console, I can actually tell Cloud Foundry which application I want it to monitor, which is great. I just say, I want AppDynamics. I want it to monitor this application. I hit go, and that's pretty much all it takes. There's a restaging process where you actually restart the application, so the instrumentation happens if it hasn't happened already. But that's roughly the complexity of it. Very, very simple. And with the single sign-on integration, it means that from within my Cloud Foundry console, I can actually single sign-on directly into my AppDynamics front end. So I have a nice single pane of glass visibility, and I can get a good view of what my application is doing via the application monitoring dashboard. I can use the power and flexibility in AppDynamics to actually create custom dashboards. Here's just one we made very, very simply that tells me about the state of the overall stack. And I can monitor the underlying infrastructure as well if I turn that feature on. Sounds good, pretty easy. We're working together on some future considerations. So I alluded to this earlier. The Cloud Foundry team has been investing heavily in a lot of the metrics components that are built into Cloud Foundry by instrumenting everything. I think at last count, there were some 340 plus metrics that are collected by Cloud Foundry. All evented systems inside Cloud Foundry are collected and made available via a log aggregator Firehose. So you could build your own nozzle and plug it directly into the Cloud Foundry Firehose and ingest all the system level information. And it can contain everything from app information, container VM, host, networking, and stack health. So the actual health of the Cloud Foundry platform. So it's more than just what I get from the kernels I get from the APM, it's the entire system level stack. It won't be as rich on application data as my APM agent would be, which is why we recommend that you actually run these two in parallel because you get much richer context from the APM agent directly for the application, but then you also get the supporting information and intelligence around the state of the stack. In terms of our joint roadmap, the tile, as we call it, should be available within the next couple of weeks. We're just going through kind of the final polish of it. We'll go to network.pivotal.io to download it. And over the next couple of months, we're hoping to add some additional functions and features, including turning on database monitoring and account provisioning in the early part of next year, and then extending to support Python, Ruby, and .NET applications before the second half of the year. So, as I said in the beginning, we're working together. We'd love to talk to our customers. We're trying to make sure that AppDynamics works very well out of the box with Cloud Foundry. And we'd love to get some feedback for early customers who have been using it and customers who actually want to use it and have specific requirements. I'll do a quick plug for two of my colleagues. So Matt Stein, if you guys were here last year at AppSphere, had a session with Alan Name from Google. We talked about microservices, and actually Matt turned a lot of those ideas into a free ebook that's downloadable from O'Reilly and provided compliments of Pivotal. And my colleagues, Josh Long and Kenny Bastani, who are very well-known Spring and Java developer evangelists, are actually running a new book that'll be called Cloud Native Java, and that'll be available sometime over the next couple of months. Okay, a couple of useful links, where to go to learn more about Cloud Foundry, where to go to download our software, basic documentation, access to the open source Cloud Foundry Foundation, as well as where the code is stored. So all of our code is actually stored on GitHub, and if you have a GitHub account, it's very easy to go dig in and have some fun with the code. I think it's roughly 8 or 9 million lines of code as of last count. My personal thanks to the folks at AppDynamics, Matt, Prantas, Mahesh, Sri, Nikhil, Naveen, and Dustin, who've been helping us over the past year do a lot of this integration along with the team at Pivotal. All right, I ran through it on purpose a little fast, so if we had any questions, we can have time for it. So there's a young lady with a microphone. If you'd please use the mic so we can record your questions. Any questions? There's one up here.
Can you discuss what you've done with the auto-scaling or the cloud connector capabilities within an AppDynamics, if you've done anything with that?
So I don't believe we've connected auto-scaling directly to AppDynamics yet. Part of it is there's two autoscalers built into Cloud Foundry. The first is the application autoscaler, which will increase the number of instances of your application that you have. And then there's an infrastructure autoscaler, which will actually increase the footprint of Cloud Foundry by provisioning additional VMs upon which application instances and DEAs can run on top of. So the two are slightly uncoupled from each other. We wanted the system level to be a declarative deterministic model because we didn't want a system parameter to just rampantly run out of control and start provisioning very expensive VMs underneath. The application one, we started very simply with a couple of metrics that we measured from the system itself. And I think over time, you'll be able to actually script that by pulling in information from AppDynamics and rendering that logic yourself in terms of, it's maybe you want to scale not based on CPU usage or memory consumption, but actually based on throughput, based on an external event that you can codify into AppDynamics that can then render increased number of instances for, let's say, there's a shopping year coming, or you see a lot of traffic going through a global load balancer, and that gives you an idea saying, hey, I need to ramp up because I think there's a lot of traffic coming through. The short answer is they haven't been bound together yet, but over the course of I think next year, we'll probably see that happen. Any other questions? All right, wonderful. Thank you very much for your time. If you guys are any of your customers or have interest, just come see me afterwards. Happy to answer questions privately. Thank you very much.